This is a review again of odds on page 6. Odds in favor. You want favorable and not favorable compared, or for and against, or NA compared to not A, right? If it's against, you want not the event not happening first and then it happening second. Now, let's skip to this part right here. Highlight this part. Highlight this part. I'm going to ask you to highlight this entire box. What is this box saying? Converting odds to probability. You need to be comfortable with that. I'm going to use green for favor. I'm going to use orange for against. Okay, so let's imagine you have odds. I give you odds, you have numbers like this. And you're supposed to convert it to probability. Okay? So probability of it happening, probability of something not happening. Watch what I'm going to do is I'm going to synchronize even. What do I do with both of these numbers when I turn it into probability? What do you see down here? This is hard, guys. Okay. And so that would be probability in favor, probability against. Guess what you do again? Okay? You're going to add. So every time you go from odds to probability, the first thing you're going to do is you're going to add these two numbers up and put them in your denominator. Whether you're going to go probability of something happening or something not happening, it doesn't matter. You're going to add up the two numbers, okay, guys? Because that's going to give you your total. Okay? The next part is where you have to read carefully. If I give you the odds in favor of something happening, so let's say today, falling asleep in Mr. Erickson's class, yeah, there's a 7 to 3 chance of that happening, right? So out of 10 people, 7 will fall asleep, 3 will not. Okay. What if I ask you what's the probability of somebody falling asleep? You're going to grab this number and you're going to put it up here. Okay. That would give you the probability of someone falling asleep. If I asked you based on these odds, what's the probability of someone not falling asleep? You'll take that second number and that's the number you put up top on your fraction. I know right now this looks kind of complicated, but I would put this on my study sheet to go from odds to probability. Okay? Let's use this right now. Why is this handy? Okay? Does this make sense why I have this bracket equals to 1? Why is that there? Well, do you remember something happening and something not happening? Like if you talk about the same event, it always adds up to 100% or 1. Okay, that's why I'm just reminding you of that. So if you get, follow my train of thought here, if you get 1 out of 5 here, this should be 4 out of 5, right? If you get 9 out of 10 here, this should be 1 out of 10. Like combined, they always add up to 1. That is your check, right? Okay, let's put this into practice here. The odds of the Jets winning the Stanley Cup is 1 to 6,000, while the Avalanche's odds against winning the Cup is 400 to 3. Who has a better chance of winning? Show your work. If you want this, turn both into probabilities. Turn odds to probabilities. Then pick highest right? That's going to be my way of approaching this. So Jets, okay, thank you. So the Jets, it gives us 1 to 6,000. 1 to 6,000. And the Avalanche gives us 400 to 3. But the numbers I find are right now are somewhat useless. Okay? What do these numbers represent? Read the question. The odds of the Jets winning is 1 to 6. Winning is the actual event that we're talking about. So because it says of winning, we know that this is W and this is not winning. Avalanche, on the other hand, it says odds against winning. What does that tell us about the first number? This is not winning, yeah. Which means that this is winning. All right. So now, why did I do that? Now we know which numbers represent winning. Okay, we need to know that, and which ones do not. So let's do our probability for the Jets winning. Question, what's going to go in the denominator? Let's do that first. 1 plus 6,000, right? That's easy, isn't it? 6,001. And I'm going to grab the 1 because that represents a probability of winning. For Avalanche, what's going to go in the denominator? 400 plus 3, correct? 403. What number goes up top if I want probability of winning? The 3. We're almost there. Can you tell which one is going to have a higher chance of winning? Some of you might, but I would say turn it into a decimal or percent. So watch what I'm going to do. I'm going to go 1 divided by 6,001. What's that? It's a very small number. So multiply that by 100. It's 0.02% chance of the Winnipeg Jets winning. We're not surprised, are we? We're not terribly surprised. Anyways, every year is different. So this. Then we do the 3 over 403. Let's multiply that by 100 as well, because we're comparing percentages. Do you need a booklet here? No. You have. Okay. So who has the higher chance? Avalanche, right? I will just do this here. I'll just do this since I'll just say 0.02% is less than 0.74%. Okay. Here, go ahead. I need you to add one more thing. We're going to go to page 4. Or can I fit this into page 8? Change of plans, because 4 is going to be used for something else, perhaps. Go to page 8, the bottom of page 8. Oh. Bottom of page 8, I'll be right there. You got it? Okay. Okay. I was going to say Belize. All right. Can you write this down, just outcome tables? I know that there are no 5-sided die, but I'm just going to make it for this question to make it a little shorter. Bottom of page 8. And I crossed that question out above it. We're not going to use that one. So if you want an outcome table, this could be you spinning a spinner on one side with 4 colors, and you're rolling a die, or tossing a coin and rolling a die. It depends. In this case, I'm rolling 2 5-sided die. And I want to know the sums. Like, what do I get when I roll a 1 and a 1? I get 2, correct? If I roll a 1 and a 2, I get 3. A 3 and a 1, I get 4. A 4 and a 1, I get 5. 6, you get the picture, right? On the other hand, this one right here, if I roll a 1 with this die and a 2 with this, I get what? 3. 2 and 2 is 4. 3 and 2 is 5. And you notice the pattern, it's going to go up by 1 every time you go over 1. 3 and 1 is 4. 3 and 2 is 5, 6, 7, 8. Four and 1 is 5, 4 and 2 is 6, 7, 8, 9. I'm already telling you that that's what's going to happen. If you follow that every time, you're going to get the same. 5 and 1 is 6, 5 and 2 is 7, 5 and 3 is 8, 9, 10. Does it surprise us that 10 is the highest sum we can ever get? No, right? Because 5 and 5 is 10. Do you notice a pattern? Anything else? What do you notice? Do you notice that there's like diagonal sums that are exactly the same? Do you notice that? So let's look at 7. If I look at 7 and how many sums are greater than 7? Is it whatever is below or above that line that I just created? Yeah, if it's below, then it's greater than 7. These are all less than 7, right? So some patterns to notice. So if I asked you, what's the probability of rolling a 7? What would you say based on your outcome table? How many possible sums do we have? 5 times 5. Do you remember? Like, if I asked you this for chapter 4, if you roll two die one after the other, how many outcomes are there? You would be like, oh, 2 5-sided die, 5 times 5, right? So same here, 5 times 5, 25 total options. So I'm going to come along this table here and just say there's 25 sums or outcomes. So how many 7s do I have? 1, 2, 3, 4. There you go. B, what's the probability of G7? I'm hoping that you will know what that means today. What's G7? Greater than 7. Of course, obviously, right? Totally. So greater than 7, how many sums do I have? I will use a highlighter for that one. G7 for me is greater than 7. So it would be all of these sums right there. So I have 1, 2, 3, 4, 5, 6. Let's highlight 7 here. Just this 7, that's those ones right there. I want it exactly 7, not more, not less. I want exactly. So that's your outcome table. That's how you use it. Yeah. Because it's greater than 7. Yeah, because this is, I want exactly 7. This is G7. Okay, I should, yeah. Greater.
Excuse the interruption, Brady and Reed to
Greater than
room
7.
30.
Make sense?
Brady and Reed to room 30.
Did I do that? For the cards, I want 7, 8, 9. Greater than 6, we didn't have any greater than 6. No, it's okay. Like, ask away. If I make a mistake, I want to own it. I don't want to own it, but I want to own up to it. Yeah. I'm just kidding. That way? Okay, I think I'm good. You're probably sweating right now. It's like, what is all this mumbo jumbo stuff? I want you to try pages 9 to 11. 9, 11.